So polymorphism in C++, we'll talk about references and pointers and how that implements implicit typecasting. And then we'll talk about a concept that's introduced in C++ that goes away in Java. It's the idea of virtual functions. Abstract base classes is a concept you've seen before in Java. You just call a class abstract and it becomes an abstract base class. And then pure virtual functions is a concept in C++ that forces a class to become an abstract base class. So, okay. So polymorphism comes from the word poly meaning many, and morph is form. So something taking on many forms. Okay, so let's go over an example that has nothing to do with classes. But let's say we had code like this. We have a float called pi equal to 3.14. And now we have a C reference, IR, an integer reference. So I'm using the letters IR. And I'm saying that's equal to pi. So I'm using IR to refer to pi. Pi is a float. IR refers to an integer. And then I print out IR. What would happen? Would 3.14 get printed out? Would 3 get printed out? Or would the compiler say you can't do this? If you were designing the language, what would you? So this is actually a C. This is not even C++. There's no class involved. So this is a C question. What would you do? Okay, so what you're saying is, even though these types are different, I'm going to let the compiler kind of wing it. The compiler can say, I can take an integer value of a float, and I don't want to make the person like really type it out or typecast it. I'll handle it myself. So basically, there's a typecast you would do implicitly. I didn't say int in parentheses, meaning telling the compiler take the float, convert it to an integer, and then stuff the result in here. It just happened automatically. So would anyone else make this a compiler error and have the programmer really spell it out to be safe?
Yeah, I would, because if it's like a mission critical application and you're losing the information in the process, and
right, if somebody came along and needed the real value of pi and made by mistake made an integer, then their computation might go wrong. But then again, do we want to keep bothering the developer, making sure they're perfect? So what ends up happening is there ends up being a warning that there is an implicit typecast, but it actually will compile. Okay, so now suppose we did something similar. Okay, so wait, okay, so suppose we did something like this. Okay, so suppose we did something like this. Suppose we had, this was what we talked about last class. Suppose we had an electronics base class and then clock and radio inherited from electronics. And then clock radio both inherited from both clock and radio. So suppose we had a radio, a clock radio, and now this, remember what the star means. An electronic star means what? A pointer to an electronics, right? And then we have a pointer to a radio. You guys printing? Someone else is printing?
I'm tired of schools mess up.
Okay, all right.
turn it off.
So let's say we had a clock pointer here and a clock radio pointer, right? So let's say, now just, you could kind of remember these declares, right? So I want to go over some questions just like the one we just covered with the float and the integer. Should this be able to compile? And if so, what would happen if you ran this code when it compiled? So if we had an electronic pointer pointing to, this would be the address of a clock radio. See, just like the float and the integer, the types don't match, but maybe the compiler can wing it and say, yeah, I think I can handle this mismatch. Or do you just say, no, this is a mismatch I can't handle? And then we use the, this should be an arrow. You know what, let me change this, because it's a pointer. When you use a pointer to make a call to a function, you say, you use the dash and the greater than to form an arrow. So I'm saying, now made a capital E. Okay. Okay. So what I'm doing here is I'm using the electronic pointer to, and I'm saying using that as a pointer, call the power up method. So what would you, if you were designing the language, would you allow this? Would you let the compiler try to wing it with the type mismatch, or would you just throw a compiler error and make the programmer fix it?
Allow it.
So again, it's kind of like, if you think about it, the analogy is like a floating point number is like an integer with more stuff, right? And an integer is a limited, like kind of like a base class to a floating point number. So the electronic pointer could point at a clock radio, and then you might be able to call functions available to an electronic. So would you allow this, or would you make it a compiler error? And I'm thinking it's similar, yeah?
How's the hierarchy going? Is it going from, do you inherit it from a parent, or is it a child?
Yeah, it's the diamond-shaped thing we had before.
Uh-huh.
So it's electronic on top, and then clock and radio on the
Okay.
sides as intermediate classes, and then clock radio inherits from clock and radio.
So they're like peers, or they, is that a child relationship, child-parent?
The electronic is the base class. That's a very high level.
Okay.
Clock radio is an electronic plus more stuff.
Okay.
So it's kind of like the analogy of like the integer and the float from the last example. So would you allow this, or would you not allow it? Yeah?
Allow it, but cause a warning, because a clock radio is electronic.
It's an electronic with more stuff,
So
right?
why can't you give it a shot, and then if it doesn't work, then it doesn't work?
Okay, so, and if we did do this, if we call the power-up routine, suppose all four classes, I put this in the comment, all four classes have a power-up routine. So if we decide to allow it, which power-up runs? The one defined in the electronics class, or the one defined in the clock radio class? Should it be the type of the pointer, or should it be the type of the thing being pointed at?
Wouldn't it be the clock radio, since you're pointing to a clock radio object, therefore you would inherit the object of the thing that it's cast as, rather than the class as a type of pointer?
So, okay, so you're saying first of all you would allow this. You would allow this type mismatch to do an implicit cast. And when you make the call, you would use the more
The clock radio one, yeah, because it's referring to a piece of storage that's a clock radio, correct?
Right.
So wouldn't it just use the clock radio one, since it's the one defining clock radio, since it's...
But at compile time, the only thing that the compiler knows about is, since this is a pointer to an electronic, it doesn't even know about anything other outside of electronics. So, like for example, suppose we use the electronic pointer to call a routine like set the time of day, which is really a radio function. It's not an electronic function. Should the actually, I think that's one of the next examples. So I'll get to that in a second. But in that one, you'd have to ask yourself, should the compiler allow it? And the compiler doesn't even know if an electronic can set a time. It wouldn't even make sense to the compiler. But in this particular example, we have a method, we have a function in electronics called power up. And we also have another function with the same exact name in clock radio. So now the question becomes, if we do allow this to compile, which version of power up should run? Should it be the type of the pointer, or should it be the power up of the pointer's type, or the power up of the thing being pointed at's type? Now, it seems logical that you would want the more senior version of PowerUp to run. But what would that involve at compile time or runtime? At compile time, we don't know what EP is going to point at. I could declare an EP and then point it at a radio, and then a little later on with an if statement I could switch to a clock, and then a little later on it could switch to a radio. The compiler doesn't know at compile time what it's pointing at. It would only know at runtime. It would have to like look and say, well, wait, what am I pointing at? And let me call that power up. It would be like a runtime decision.
Well, it should compile then, because if it's basing it off an electronics class, it will see that there is a power-up method in the electronics class, so it wouldn't throw a mismatch error.
Right,
Because there is a power-up method.
exactly. So the fact that the method exists in the electronics will allow it to compile. Now what you're saying, and this is a good idea, at runtime it would be preferred if we said, well, skip the one that's, skip the base class version, I have a more sophisticated version, I'd rather run that one.
Therefore, it would run the one defined in the storage.
And that decision would have to be made at runtime to figure out, as it's about to call it, it would have to like figure out what am I pointing at the moment, and then find that routine and call it. But that would still be, would anyone argue that we should call the base class power up, not the derived, not the thing we're pointing at, but the type of pointer? Would anyone think, can anyone think of a scenario where you would want the base class one, not the one you derived to run instead? Or would you, forget about if you could think of a real world example, would you want to allow that to happen? Or would you want the programmer to have a choice which one to run? So there's four answers to this question. We can make it not compile. We could make the power up of the pointer, electronics, run. We could at runtime make a decision to find out what we're pointing at and then call that one's power up, if it happens to have a power up. It may not, which means we have to go back to the base class one. And then the fourth choice is we could allow the software developer who created these classes to write the code in such a way that they can make the decision when they're writing the code. So this question really has four answers to it. So it's a matter of what do you think makes the most sense. So now let's say we had another example. So we'll go through like 3 or 4 examples and just have some thoughts in our head. So suppose we had it now the other way around. Suppose we had a clock radio pointer pointing at a radio. So now the type of the pointer is the most derived one, and it's pointing at something it derived from. And then we used the clock radio pointer to call power up. And again, all the classes have a power up. What would happen in this case? So in the last case, the pointer was of the type that's high in the class, pointing at something low in the class. Now something low in the class is pointing at something higher in the class. Would you allow this to happen? And why or why not? Does anyone have any suggestions for this question?
I mean, typically you will allow it though, right? Like, if it's the base class die, isn't that the same idea? You get into base class methods and that's what you call it, you call it base.
This. All right. So we're. I'm sorry. Say that again. So if we were.
Yeah, like if you call in the base, it's like calling the base class dot whatever the function.
But would you allow this to compile? Is there any danger to allowing this to compile? This one. I'm using a clock radio pointer to point at a radio. From the point of view of the compiler, if I use the clock radio pointer to do something clock related, like set the time of day, I can call set time of day with the clock radio pointer. That would make sense to the compiler. Clock radio can set its time of day. What if I try to set the time on a radio?
Then you do compiler error.
Yeah, it wouldn't make sense.
At runtime or compile time?
It's a
Be
compile.
a
First-
runtime, because a compiler would just check the base type.
Yeah, I would think it'd be a runtime first set.
So you would let,
Is it whether we would let it or whether the compiler would let it? Just always one
well, so the thing is this, if we did do that and I called set time, you would let that compile. And then at runtime go, wait a minute, I can't set the time, I happen to be pointing at a radio only.
Wouldn't it just throw away that value? Because it had nothing to really set?
Well, this is a language design question. Would you let the language call a function on an object that may not, the thing you're pointing to at the moment may not apply to? And if so, what would you do? So you would say somebody thinks this clock radio pointer is pointing at something with a clock function to it, and it turns out it's not, it's just pointing at a radio, and they go to set the time of day, you would say, well, that doesn't make sense, I'll just go to the next line and not set the time of day, or would you make it a compiler error so that the scenario could never occur?
I prefer it doesn't occur.
Well, yeah, you prefer it doesn't occur, but sometimes we want to let things go because it might be what the developer wanted. Sometimes,
Why are they not using proper types to begin with?
why are they using mixed types?
Yeah, clock radio to point to a radio, and it's just a radio point.
Well, wait, that goes back to the original question of should we allow mixed types at all? Should we allow a float to be put into an integer value, or should we just say, no, that's a compiler error?
That
Clean.
part will
It's
that'll
like-
fail. That'll give you
yeah,
a compiler
that's-
error.
Putting a float into an int?
I mean,
A reference to it.
it might change it. Would
That
it
your
change
pi
it?
example, that fails.
Change the type, because it would be changing to an integer
I think it
value,
would
so
change it.
truncated.
It would
Well, no, no.
change the float to an end,
Wait,
right?
so the original question is saying, do we allow implicit typecasting if the compiler thinks it could wing it? And so the topic of polymorphism is that we would allow this. We can have an array of electronic pointers and have them point at clocks and radios and iPads and anything we can make that's electronic. But then the question becomes, could we use that pointer to start calling methods that are very specific to certain devices that other ones may not have? And should the compiler say, no, that's no good, or should that runtime we say, no, that's no good? Or should, decisions be made at runtime?
You should check it, it's good practice, you should have the compiler check to make sure that the things run, because if you allow the code and if you allow it to compile and it just won't work, then your program doesn't work. Therefore, there's no point to the program, because it would be stuck on that.
Well, no, the compiler can do checking that tells you whether you can and cannot let this run. Then sometimes at runtime, things that the compiler couldn't find, like if you divide by 0, the compiler can't know that, it'll have a problem at runtime. So the question is, if we allow these type mismatches to go through, we don't want to open ourselves to runtime errors where we could be calling a routine that's not there. We could be calling a clock-related routine on a radio, and it doesn't make any sense at that point. Now we have to have a runtime error saying you can't set the time of day for a radio. So do we want to even allow that?
Doesn't it depend if you're going up as opposed to down?
Yeah.
So,
So,
if you're
I mean,
going
would that
up,
be a
then
good
you can
design?
do it. Yeah, because if you're, like, for example, like, bird, if you can add on a bird, so if the bird was called the animal classes, that would be fine. The animal should be able to.
Right, like so if you use an animal pointer to refer to a bird, you can call functions, but you couldn't call bird-related functions because the compiler doesn't know for sure you're pointing at a bird. But you could call animal-related functions.
Yeah.
But if you had a bird pointer pointing at an animal, and you start calling functions like start flying, it might be an animal that can't fly, and then that call makes no sense. So what they end up doing is deciding that pointers and references of base classes can point and refer to derived classes, but you can only call functions that exist in the base class. And then if you repeat the function in the derived class, now an interesting question comes. That would get past the compiler. Now the interesting question comes at runtime, which of the two versions do you call? Do you call the power up of the base class or the derived class, or should the programmer have a choice which one gets called? Okay, so another question just to think about. Suppose we had a radio pointer pointing at a clock radio. This, now, you're saying this should be allowed because radio is higher up in the hierarchy. It can point at something that has radio plus other functionality, so that this should compile. But can I call set volume
No,
on the radio?
she's going down.
Yes.
It has a second method.
Yeah, because set volume is part of a
You're asking
radio.
a radio pointer to perform a radio operation on the radio.
Right, so since, from the point of view of the compiler, maybe this is pointing to a clock radio or maybe not, and the compiler won't know that at compile time, but it knows for sure it can do radio stuff. So we can call a radio function and the compiler will allow it to go. Now the question is, if clock radio rewrote the set volume function, which of the two? Should it be the radio one or the clock radio one? That's something we'll talk about in a second. And then what about something like this? A radio pointer is pointing at a clock radio, and then we use the radio pointer to set the time of day. Should this be allowed, or should this have a compiler error?
Yeah.
This would be an error because radios don't, setting the time of a radio doesn't make sense. And this would only work at runtime if we happen to be pointing at a radio that involves a clock. And we can't be, the compiler can't be guaranteed that's going to happen. So they don't want to have a runtime error because it allowed this to compile. So this would not compile. So then the question becomes, what do we do? So what we can do is have a base class pointer pointing at a derived class object, and we can only call base class functions. If the base class and the derived class both have a function with the same name, then we get into this discussion of which of those two functions should we call. It seems logical that derived class one would make more sense because the person went out of their way to write it. So it's more logical for that object. But this would have to be decided at runtime. So in C++, the designer of the base class has a choice. They could say, if somebody inherits from me and writes the same exact function, then, and then if they do this polymorphic situation where they have the thing referring to it is of my type, but the thing I'm referring to at runtime is some other type, if I can allow the other type's version of the function to run, or I can block that from happening and force mine to run as the creator of the base class. So an additional keyword was added to the language called virtual. If you put virtual in front of a function, you're telling the runtime environment, if somebody calls power up by using a pointer or reference of my type, but is referring to something of a derived object, and that happens to have the same function, then at runtime make the decision to use theirs, not mine. If they don't have one, then come back to mine, because that's the only one that there is. But if they took it upon themselves to rewrite this function, use theirs. That'll happen if the keyword virtual is put in front of the function. If the designer of the base class doesn't put that there, then you have to use theirs. The one that you wrote can only be called if you use a reference of your type, not their type. So the word virtual being there allows, at runtime, allows us to switch, like you were suggesting, to use the one of the derived class. So that's what this new word virtual is. So let's see. So a function that does not have this word now we refer to as non-virtual functions, even though that's by default. You don't say non-virtual, it's just you leave out the word virtual. So with non-virtual, which is by default, function, the type of the pointer or reference determines the function definition that's used. For virtual functions, using this new keyword, however, the class of the object pointed to or referred to will determine the version that's being used. So in C++, the creator of the base class determines the choice if they want to force theirs to be used or allow the freedom of the inheriting class to override it and use theirs instead. Yes?
Well, my question is, so if you call this method virtual void power up, the
Right.
stuff that you put in there for the actual function is only going to be called on.
The stuff that's in the
Yeah,
function.
in there. That stuff will only be called if the other one doesn't have a power up function, or is that automatically called?
Okay, so in a situation where you're using a pointer or a reference of this type, of electronics type,
Yeah.
to refer to something that was derived from electronics, if the word virtual is here, that means at runtime, if you take this pointer
And it's pointing to a clock radio.
and it's pointing to a clock radio, at runtime a check will be done. Does clock radio have a power-up function?
And if yes, it just gives
If
over-
yes, use that one.
Okay.
If no, then come back to this one
And then run that. Okay.
and run this one.
Okay.
And if the word virtual is not there, then you're gonna run this one,
Okay.
and the other one will be skipped. Now the question becomes, can you think of a real-world example where the creator of the base class would not use virtual and say, I insist that you use mine, not the one you created for yourself? Like, I'm gonna throw a tantrum, you have to use mine. And if you don't think there's a real-world example for that, you might consider getting rid of this virtual, make every function virtual. Why have non-virtual functions? So that's something to think about. But in C++, we have the option. The creator of the class can say, no, I insist you always use my function, not the one you wrote, which is really for what you're interested in. Okay, so then just some random facts. I don't want to call it fun facts, but so about virtual functions. Okay, the names of non-virtual functions are bound at compile time. So if they're non-virtual, the compiler knows exactly what method's being called. It's the base class one. Okay, the names of virtual functions are bound at runtime. So that means the decision is made at runtime which function is made, which function ends up being called. Okay, it's illegal to have a derived class function with the same name and argument list as the inherited one, but a different return type. If this was allowed, it would make it impossible for the compiler to know which function to run. Constructors cannot be virtual. A virtual constructor would be useless because the constructor will always call the base class and then the derived class. If we had a concept of a virtual constructor, that would then cause only the derived class constructor to run, and this one would be skipped. So constructors are special. They run when the object is being created. So the idea of a virtual constructor doesn't make sense. But virtual destructors are allowed. This would allow the derived class to say, don't run the destructor of the item I inherited from. I know I have a different way I want the whole thing being destroyed. Okay, so then the concept of an abstract base class. So what is an abstract class compared to a non-abstract class? An abstract class is something that you might use for design purposes, but you would never create an object of this type. So for example, in this clock radio electronics paradigm, we would create an object for every product we make. So we might make 10 radios, so we'll create 10 radio objects. But would we ever create an electronic object? We don't sell electronics, we sell electronic things. So in that sense, the electronics class is really abstract. We would never make, it's not real, it's not something we'd ever make. However, it's necessary because every electronic product might have things in common, like the company's logo and a power-up method and a serial number. So there might be things that all the electronics have in common, but we would never actually create an electronic object. So really, that class is abstract. We would never want to actually create one. And it would be nice if we can tell the compiler, don't ever allow anybody to create this, it doesn't make sense. So that's the concept of an abstract class. Yeah?
So you wouldn't even use the abstract classes methods, or you would depending on if
Well,
you use the word
you
virtual?
could. So that's a good question. Suppose we created an abstract class called electronics. We had a field in it called serial number. And let's say we had a method called power up. And all that method does is whenever we power something up, we display the company's logo. And that's it. Now, the clock class would also have a power up which sets the time of day, 12 noon or whatever. And the radio might have its own power up. What do? A power up method would be called when we plug the device in. So we might start calling a series of power up methods. When we're powering up a radio or a clock radio, we might display the company's logo, which came from the electronics method, and then set the time of day and set the volume of the radio. And so there might be a whole sequence of stuff that happens when we power up a clock radio. So we could have the methods in an abstract class. Some of them could still have instructions in it. And we might also have data, like, for example, the serial number. We might have a field to record the serial number. Okay, so a function that has this added to it. So there's a concept, it's not a keyword, but it's a concept of a pure virtual function. It's like before we put the word virtual in front of the function. That means at runtime make a decision to figure out which power up to run. But if we add this new thing where we say equals 0, this is saying that this particular function is called what we call a pure virtual function. And you do this by making it a virtual function and setting it to 0. So what is a pure virtual function as opposed to just a function? Okay, so pure virtual function, fun facts. If a class has one or more pure virtual functions, the class is considered abstract. That would mean if you ever tried to create one of these things, the compiler say it's not possible, this is an abstract class. So the way in C++ you make a class abstract is you have to have at least one pure virtual function. Okay, then objects cannot be instantiated from an abstract base class. If a class inherits from an abstract base class and does not override all the pure virtual functions, then it too is abstract. So in other words, you cannot instantiate something unless you got rid of all the all the pure virtual functions. So why would somebody create a pure virtual function? You're basically saying, I want this class to never be instantiated. It's an abstract concept class. And anybody who inherits from me, I want to force them to give a body for this method.
So it's almost like an interface.
It's very close.
It is.
It-
It is.
Well, wait, before I show the last slide, yeah, it's close to so an interface in Java is a method with no body, and if you, implement the interface, you're required to fill in the body.
You can
Okay.
basically make an
You're not required
interface
to.
in,
What?
you can make an interface then in C++.
You can make one, yeah, so that's on the last slide. So before the last slide, we'll throw a trivia question up, just to see if you get the concept of this. Okay, so an abstract base class that never gets inherited from is pointless. Right? An abstract class can never create anything. And if you created an abstract base class by throwing in at least one pure virtual function, and nobody ever came along and inherited from you, then what's the point? Nobody's getting any use out of it. So an abstract class takes on the name abstract base class, implying it's supposed to be inherited from. So that's why they end up, you might think these should be called abstract classes, classes that will never be created, instantiated from. But the fact that an abstract class that never gets inherited from is completely pointless. Obviously, this is meant to be a base class for something else. So that's why they end up being referred to as abstract base classes. So that's why the word base comes in. Okay, so now how is this implemented? This idea that if I take an electronic pointer, which happens to be at the moment pointing at a clock, and call power up, how do I know which power up it is? And at runtime, the storage that is given for the base class has an additional pointer added to it if you have one or more virtual functions. That means you might call the function from your base class, or you might call it from the derived class, and a decision has to be made at runtime. So if the decision has to be made at runtime, we have a pointer. We have what they call a V pointer, which is virtual table pointer. Points at a table, and then the table has the addresses of all the functions that you should be calling. So at runtime, if you invoke a virtual function, at runtime the pointer checks this table, and this table was built by the compiler, no, it was built during runtime to point at where the function you should be calling is, and then you go and call that function. So there's a little cost to allowing this virtual versus non-virtual concept. One cost is you have to take up space for one additional pointer. So if your storage for your class had 50 fields to it, now it has 51 fields. There's an additional storage for the pointer. Then we have to create a table for the pointers to every method you have. And then there's a time cost, because at runtime, when you go to make the call, this code by the runtime environment has to check this table to get the address and then know which function to call. So there's a small storage and time loss in allowing this virtual versus non-virtual idea. Okay, so before I show the last slide, so the last slide is what's the difference between, Java and C++. So before I show the last slide, C++ doesn't have interfaces, but does allow multiple inheritance. What is the connection between an interface? How could you simulate an interface, a Java interface, in C++?
There's a bunch of pure.
Yeah.
Having two or more pure functions, such as 0.
Well, okay, so to make a class abstract, you have to have one or more pure virtual functions. A pure virtual function is a function that is virtual and equals 0.
Yeah.
So you would have to have at least one to make it abstract. And what else would be like an interface? Would it be one of the methods has to be
The whole
abstract?
thing.
All of them.
All of
The
them.
whole thing.
Yeah.
Right, and an interface in Java and C#, you get all the functions have no body, and you're requiring the person who implements it to provide a body. Okay? So you would, if you created a special type of abstract base class where not one, but all the functions were pure virtual, and what other rule is there for Java interface? They have no data.
Yeah, no data. And
So, and here, we can make an abstract base class with data. Like, we can make an abstract electronics class, and we could still have a data field called serial number, and that's allowed. But if we took it upon ourselves to not put any data in, and also make every function pure virtual, then we inherit from that. Any class inheriting from that would be required to give the body and would receive no additional data. And inheriting that type of abstract base class would be like an interface in Java. So let's see.
so it seems like there's a lot more freedom behind C++ than a lot.
I guess so. So the difference between, so Java changes were, as far as the topics we've talked about tonight, Java added the keyword abstract, so, which kind of makes perfect sense. I mean, it looks kind of ugly. You have to go fishing through the class looking, oh, I just found a pure virtual function, therefore this class is abstract. So Java let you put this word on top, just say this class is abstract. Nobody should ever create from it. And then, so that would be to declare abstract base classes and remove the concept of at least one function with an equal 0 has to exist. Okay, Java removed the virtual versus non-virtual choice by just saying everything's virtual. We should always decide at runtime which method to use. Why allow the base class designer to say, I refuse to let you use your method, you must use mine? Maybe because they couldn't, yeah?
Well, if you wanted to use like the higher classes method, then you wouldn't even write your own in Java, right?
Right, that was kind of their argument. Why would the derived class bother to write a method if the class they're inheriting from could say, you're not allowed to use it.
Yeah,
Like,
waste of time.
yeah, why give the base class person this choice to block you from using your method? So they just said every method is what C++ calls virtual. So now that since every method is that way, we don't need this extra word to turn it on or off. It's always on. So they took the word virtual out and just made every method virtual. And then the last one, which I thought would be the most confusing, but you guys jumped all over this. A special abstract base class with no data and all functions being pure virtual is referred to by C++ programmers as an interface. They always refer to it that way, just like, you know, oh, if you do it this way, we'll call that an interface. And then Java came along and actually made that part of the language. So Java removed multiple inheritance, but it created interface that allows you to implement this instead of inheriting it. You would implement it instead of inheriting it. So Java, you know, claims it doesn't allow multiple inheritance, but it does allow you to inherit once, and then this special type of abstract base class where there's no data and no method bodies, it allows you to implement, but we're really like kind of inheriting it as many times as you want. So the thing that we're trying to avoid was, let's say for example, last class someone said we could create a new electronics called a CD player. Suppose the radio had a field in it called volume, right? Volume is an integer, from 0 to 10. And the CD player had a volume, also called volume. And we made a, what do we say we're going to inherit 3 ways? We're going to make a clock, radio, CD player. We would get 2 volumes. 2 fields with the same exact name. Now, which one are we talking about? Are we talking about the radio's volume or the CD player's volume, or should they get merged into one? That's a problem with allowing you to multiply inherit from 2 things that have data. The data fields may match in name. Also, the method names may match in name. So that's what's kind of the idea of, you get rid of that problem if you have a special class that has no data. Then you won't have data collisions. And then if the methods are all pure virtual, that requires someone else must provide it. So you'll never have the scenario where you have 2 methods with 2 different bodies competing with each other. If one of them guarantees to provide no body, then you would use the body of the other one and there's no confusion. So that's why Java allows inheritance once, but allows this kind of obscure abstract base class where all the functions are pure virtual and there's no data. It avoids all collisions, either on data or method names. It blocks the collisions from happening. So technically they allow multiple inheritance, but you're allowed to inherit from one class that's unlimited as far as data and methods, and then every other class Java allows you to inherit from must be what C++ would call an abstract base class with no data, and every method is pure virtual. And that avoids all collisions in the multiple inheritance, so that they allow. Okay.